Question 3 says the rate of flow Q of a liquid along a narrow pipe of length L and radius R is given by the equation Q equals alpha R to the 4 over L, where alpha is a constant. An experiment is carried out to determine the value of alpha. The data from the experiment are shown in table 1.1. Use the information in table 1.1 to show the SI base unit of alpha is seconds to the minus 1. So if I just rearrange my equation first, I'm able to write alpha is equal to QL over R to the 4. So in terms of units, the units of alpha are the units of Q times the units of L over the units of R to the 4. So the units of Q are meters cubed seconds to the minus 1. The units of L are meters over the units of R are meters, so the units of R to the 4 are meters to the 4. So on top we've got a meters to the 3 and a meters to the 1, so we're going to put those together as meters to the 4, still seconds to the minus 1 over meters to the 4. So we can see we're just left with seconds to the minus 1. Just going to choose a thinner pen. Show the percentage uncertainty in alpha is 15%. So the error in alpha as a percentage. So looking at how this is arranged, we've got Q times L divided by R to the power of 4. So we're going to have to add up the percentage uncertainties, and R affects it 4 times. So this will be the uncertainty in Q as a percentage plus the uncertainty in L as a percentage plus 4 times the uncertainty in R as a percentage. So the uncertainty in Q is 3 plus the percentage uncertainty in L is 4 plus the percentage uncertainty in R is 2, but we've got 4 lots of it, so 4 times 2. So that's 3 plus 4 is 7 plus 8 is 15%, as we were asked to do. Calculate alpha with its absolute uncertainty. Give your answer to an appropriate number of significant figures. So alpha, as we've just said, is QL over R to the 4. So our values of Q is 2.72 times 10 to the minus 8 times L is 2.5 times 10 to the minus 2 over R, which is 7.1 times 10 to the minus 5 to the power of 4. We should note down at this point that our values of R and our values of L are to 2 sig figs, whereas our value of Q was to 3 sig figs. Then our next job is we're going to work out the size then of this quantity. So when we do this, we'll work it out, and we can only quote it to 2 significant figures because of our value. So this comes out as 2.7 times 10 to the 7. So we can put that straight in here. Then our uncertainty, as we established back up here, was 15%. So on uncertainty we just need to take from a percentage to an absolute value. So the uncertainty in alpha should be equal to 0.15 times the value of alpha, which is 0.15 times 2.7 times 10 to the 7, which gives us, so if we're going to write it down, we need to write to the same number of significant figures. So it makes most sense to write it as 0.4 times 10 to the 7 when I come to write it down. So here I can put in my 0.4 times 10 to the 7 so that it's quoted to the same number, to the same precision, so the same number of decimal places as my result.